Okay, so here are the answers for your review sheet for test number 1. So let's take a look at number 1. It says determine if the following even, odd, or neither. All right, so number 1, which is f of x, is equal to x to the third minus 2x. So we're going to take a number and plug it in. So let's plug in 2. F of 2 equals 2 to the third power minus 2 times 3. Oh, sorry, 2 times 2. And that comes out to be 4. And then we'll plug in the opposite, f of negative 2. So it's negative 2 to the third minus 2 times negative 2, which comes out to be negative 4. So when they're opposites, that means it's odd. Okay, you also have to know how to do this algebraically. So f of x, remember, it's just x to the third minus 2x. Now I want to do f of negative x. So that's negative x to the third minus 2 times negative x. So negative x to the third is negative x to the third. And then negative 2 times negative x, that's positive 2x. So you could see here, this here, right? This is positive x to the third, negative x to the third, negative 2x, positive 2x. So these are opposites. Right? So these are opposites, and that's odd. Okay, make sure you know what would be the reason. So it's odd because it is a rotation of 180 degrees. Okay, so let's take a look at B. Okay, so B is g of x is equal to 4x squared plus 2x. So we'll start off with g of 2. So that is 4 times 2 squared plus 2 times 2, which comes out to be 20. And we will plug in g of negative 2, which is 4 times negative 2 squared plus 2 times negative 2, which comes out to be 12. So they're not the same, they're not opposites, so this is neither. All right, so now let's do it algebraically. So that is g of x is equal to 4x squared plus 2x. G of negative x is equal to 4 times negative x squared plus 2 times negative x. So I get negative x squared is positive x squared, so that's 4x squared. And then 2 times negative x is negative 2x. So we can see the 4x squared and the 4x squared, that's the same, but then 2x and negative 2x, that's opposite, so it's neither. All right, so it is neither odd nor even, because it is not a rotation of 180 degrees. And it is not symmetrical to the y-axis. Okay, symmetrical to the y-axis would be when it's even. Okay, so let's take a look at C. All right, C is h of x is equal to 3x squared plus 4. And I'm going to start off with h of 2. So that's 3 times 2 squared plus 4. So this comes out to be 16. H of negative 2, it'd be 3 times negative 2 squared plus 4. That also comes out to be 16. So these are equal. Therefore, it's even. All right, algebraically. So h of x is equal to 3x squared plus 4. H of negative x is equal to 3 times negative x squared plus 4. So negative x squared is x squared times 3 is 3x squared. plus 4, you could see we get the same exact thing. This is the same as that. Therefore, equal is even. And it's equal. Oh, sorry, it's even. Sorry. Even because it is symmetrical to the y-axis. Okay, so let's take a look at number 2. Okay, so number 2 says to find the difference quotient in simplest form for each function. So here's the formula for the difference quotient. Remember that h of 0 just means you can't have 0 in the denominator because then it's undefined. All right, so let's start with A. Okay, so here's my formula, and here's my function 6 minus 5x. So you're following the formula. So I want f of x plus h. So I'm going to plug x plus h in for my x here. All right, so I have 6 minus 5 times my x, which is going to be x plus h, minus my f of x, right? Minus f of x. My f of x is a binomial, so I have to use parentheses, over h. Now I need to simplify this. So distribute the negative 5, distribute the negative 1. So it's 6 minus 5x minus 5h minus 6 plus 5x all over h. Now let's simplify this, combine like terms. So 6 minus 6 is 0. Negative 5x plus 5x is 0. So I'm left with negative 5h over h. H and h reduced to 1 and 1. So my answer is negative 5. All right, let's try B. Okay, so we have the same formula. So remember, wherever I see an x, I'm going to plug in h plus x. So it's going to be here and here. So start off with. All right, so we need f of x plus h. So it's going to be x plus h squared plus 4 times x plus h minus 2. And then I need minus my function. So minus parentheses x squared plus 4x minus 2 all over h. All right, so I'm going to work on this here. So I'm going to do this up top here. So x plus h. So x plus h times x plus h. So that's x squared plus xh plus xh plus h squared. So that's x squared plus 2xh plus h squared. Distribute the 4 plus 4x plus 4h minus 2. Now distribute the negative. So minus x squared minus 4x plus 2 all over h. Now let's combine like terms. So x squared and x squared minus x squared is gone. 4x minus 4x is gone. Negative 2 plus 2 is gone. So I'm left with 2xh plus h squared plus 4h all over h. You have to reduce the h's, all three of these h's. So h reduces with h here to 1 and 1. H and h squared reduce to an h and 1. And h reduce to 1. So I have 2x plus h plus 4 is my answer. Okay, so let's take a look at number 3. Okay, so number 3 says, what is the domain and range for each of the function expressed in interval notation? All right, so let's start with A. Okay, so let's start with the domain of my x values. Now, I noticed that for my domain, I have a radical. So now think about what you can't have with a radical. What's underneath the radical, the 5 minus 3x? That can't be negative. It can be 0, so it has to be greater than or equal to 0. And now you're going to solve this. So, well, minus 5, so negative 3, x is greater than or equal to negative 5. Divide by negative 3. Remember, when you divide by a negative, you flip the sign. So it's positive 5/3. So every number less than 5/3. So that would be from negative infinity to positive 5/3. Okay, now for the range, what you should do is just draw yourself a little picture. Right, so 5/3 is like 1 point something, so it's like over in here. So it looks like this. So your range is going from, so I think it's going like that. Your range is going from 0 to positive infinity because it just keeps going up and up and up. Okay, so let's take a look at B. Okay, so for B, for the domain, I noticed that my x is in my denominator, and my denominator for a fraction cannot be equal to 0. So it's 3x cannot be equal to 12, so x cannot be equal to 4. So x can be any number, it just can't be 4. So it's from negative infinity to 4, union 4 to infinity. All right, when you graph this, your graph looks like this. So your range is every number up and down except 0. So this would be your range. Your range then is from negative infinity to 0, and union 0 to infinity. All right, let's take a look at C. Okay, so for C, I noticed that I have a fraction, so I can't have 0 in the denominator, and it's a radical, so it can't be negative. So I have then that x minus 7 has to be greater than 0. Can't be 0, remember, because I would have 0 in the denominator. So I would have x is greater than 7. So then it's 7 to infinity is the domain. And graph it to see the range. So I graph it, and so over here it's 7, right? Because it has to be every number greater than 7. It looks like this. Okay, so it's from 0 up to infinity. So this would be my range, 0 to infinity, because not hitting 0. This here is an asymptote. All right, let's take a look at 4. Okay, so 4 is finding the domain and range from the graph. So this should be fairly easy. It's easier than the equations. All right, so the domain for the first one is how far left to the left it's going, and it's going right to this number here, which is negative 8, and then it keeps going to the right. So my domain would be from, I believe that's negative 8. So it's going from negative 8. Oh, sorry. I don't know why I wrote that like that. It's going from negative 8. Oh my God, I did the same thing again. To infinity. And my range, which is the up and down, so it's not going past, let's see, this is 5, 6, 7. It's not going past negative 7, so it's from negative 7 to infinity. And this was a parentheses because of the open circle. So then my range is going to be from negative 7 inclusive to positive infinity. Okay, let's take a look at B. My domain is from left to right. Now it keeps going down to left, keeps going down to right. That means it's from negative infinity to infinity because it's all real numbers. And the range is your up and down. So it's not going up past 8, but it keeps going down to infinity. So it's from, this is your range, negative infinity to 8 inclusive. Okay? Remember, infinity always gets a parentheses. All right, let's take a look at number 5. Okay, so number 5 says, for each, approximate the relative mins and maxes, zeros, and find the interval where the function is increasing and decreasing. So you're going to graph these. And you're going to start by finding the maxes. So graph these on your calculator. So here's the first one. Here's A. All right, so when I graph this, it looks like this. Okay, so you're going to find the max. You're going to use your calculator. The max comes out to be negative 2.5, comma 9.25. We have our zeros. So this 0 here is negative, so x equals negative 5.54. And this 0 is x is equal to 0.54. We have draw a number line underneath to find the increasing, decreasing. You are going to put on the number line the x value for your max, which is negative 2.5. And it's increasing on this side. And it is decreasing on this side. So it's increasing from negative infinity, comma, to negative 2.5. And it's decreasing from negative 2.5 to infinity. All right, let's take a look at B. Okay, so the graph for B looks like this. Okay, so let's start with the max. So this max right here is negative 2.7, comma 9.5. And the minimum, which is also now one of your zeros, is 0, 0. So I have my max, my min. One of my zeros is x equals 0. The other 0, which is right there, is x is equal to negative 4. And now I need where it's increasing and decreasing. So you're going to plot the x value for your max and your min. All right, so it's increasing here, decreasing here, increasing in here. Okay, so it's increasing from negative infinity to negative 2.7, and it's also increasing from 0 to infinity, and it's decreasing from negative 2.7 to 0. Okay, let's take a look at 6. Okay, so 6 is your transformation, so you have to just come up with the equation for the transformation who has a parent function of x to the, sorry, the paper is blurry, x to the third power. So let's see here. I have my parent function is x to the third, so I want to shrink of 1/3, that's a dilation, so that's a multiply. I want to reflect over the x-axis, so that means you have to change your y value. And to the left, 7, that means it has to be inside the parentheses. So it should look like this, your transformation. Negative, that's the reflection over the x-axis, shrink of 1/3 times your y now, which is going to have an x, and then it's to the left, so we want to move it left and right, so it has to go just to the x, plus 7. Remember, it's opposite the way you think it goes. So that would be g of x. F of x, well, we want a stretch of 4, so that's 4 times. To the right, 6. Sorry, it's absolute value. So it is a stretch of 4, and then it's the absolute value. And then it is to the right, 6, so that means minus 6. And then down 2, that's on the outside because you want to do the shift to your y value. All right, so from the graph here, let's see what we have. All right, so it looks like I have a reflection over the x-axis because I'm going from a parabola opening up to a parabola that's opening down. So I have a reflection over the x-axis. And so when you reflect over the x-axis, you have to change y. That means it has to be on the outside of the parentheses. Okay. And let me just move this. So g of x, I just need more room. G of x is equal to, so reflection over the x-axis. And then I need, so once I reflect it over, it is to the 1, 2, 3, 4, to the left 4, so that's x plus 4, and then up 2, which would be plus 2. So the reflection is first. All right, and let's take a look at D. So D is reflection over the y-axis, which means it changes x to its opposite, so it's going to be negative x like this. And then it is up 1, 2, 3, 4. It's up 4. So that goes on the outside plus 4, not underneath that radical. Okay, so this should be a little short there. Okay, so let's take a look at, that was 6. Let's take a look at 7. Okay, so 7 is identifying the transformation from the equation. All right, so I notice I have to do what's on the inside of the parentheses first. All right, so on the inside of the parentheses, I have a plus 2. So that means it's to the left 2. And then I have a reflection because I have that negative on the outside. And that's changing the y values to its opposite. So it's a reflection over the x-axis. Reflection over the x-axis. It's a dilation of, a dilation of 3, which means a stretch of 3. And then it's down 1. And you have to make sure you have them in the right order. All right, 7b. So inside the parentheses, I have the multiplication first, the reflection. It's changing x to its opposite. So that's a reflection over the y-axis. And minus 1 to the x, which means to the right 1. I have a multiplication, so it's a multiplication of a half, so it's a shrink of a half, and then plus 8 on the outside is up 8. All right, let's take a look at number 8. Okay, so number 8 is to find the average rate of change. So remember the formula for the average rate of change. The average rate of change is, let me just write down the point for A. All right, so the average rate of change, which is your slope, right? So that's the average rate of change. So it's y minus y over x minus x. All right, so it's y minus y. So it's 5 minus negative 7 over negative 3 minus 3. 5 minus negative 7, is 12 over negative 3 minus 3, which is negative 6. So this is negative 2. All right, and then let me change my points. So my other points are going to be, I'll do it right here. So my other points here, let's see, we have y minus y. All right, so we have negative 6 minus negative 2 over 0 minus negative 2. So that's negative 4 over 2, which is equal to negative 2. All right, that was for B. All right, let's take a look at number 9. So number 9, is to evaluate. So remember, you're going to take this here, that's your input. You're going to plug it into your x value there. So it's 3 times 2x plus 3. So that's 6x plus 9. Okay, that's for A. Oh, sorry, and I forgot the plus 5 here, plus 5. That was from back here. Sorry about that. So it's 6x plus 14. All right, let's take a look at B. All right, so I'm going to take x minus 2, plug it in for the x and then square it, and then multiply that by negative 3, and then add 4. So it's x minus 2 squared minus 3 times x minus 2 plus 4. Remember, x minus 2 squared is x minus 2 times x minus 2. Okay, so I'm going to double distribute. X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. I'm going to distribute the negative 3 to the x, get negative 3x, and then plus 6 plus 4. Combine all the like terms, so I have x squared. This is negative 4x, and negative 3x is negative 7x. 4 and 6 is 10, plus 4 is 14. All right, so let's take a look at number 10. Okay, so number 10 says, given the equation and a point, you want to use slope-intercept to write the equation of a line parallel. So remember, parallel lines have equal slope and passes through the point. Use point slope. Remember, this one's y equals mx plus b. This one's the other formula. to write the equation line perpendicular. Remember, perpendicular lines have negative reciprocal slopes. And then put them in general form. General form is to get it to equal 0. All right, so let me write down the equation, because the first thing we need to do is take the equation and put in y equals mx plus b form. So that's 3y minus 6x plus 7 is equal to 0. So I'm going to take this now and put it in to y equals form. So I'm going to add the 6x and subtract the 7. So 3y equals add 6x, subtract the 7, and then divide by 3. So I get y equals 2x minus 7/3. So the slope of this line is 2. My parallel slope is also going to be 2. So then what I want to do now is to write my equation that passes through the point negative 8, 6, and is parallel. And I want to use slope intercept. That's y equals mx plus b. So I'm going to have y equals 2x plus b. In order to get b, you have to plug in x and y. So it's 6 equals 2 times negative 8 plus b. So it's 6 equals negative 16 plus b. So b, add 16, is 22. So my equation is y equals 2x plus 22. All right, let's take a look at the next one. All right, so now I want to have perpendicular. So my perpendicular slope is the negative reciprocal, which is going to be negative 1/2. And I want to use point slope form. So that's this one. Y minus y1 is equal to the slope times x minus x1. It's still going through negative 8, 6. All right, so I plug in my point into y1 and x1 and my slope. So it's y minus 6 equals negative 1/2 times x minus negative 8. Fix the x minus negative 8, that's actually plus 8. So y minus 6 equals negative 1/2 x plus 8, and we'll distribute the half. Y minus 6 equals negative 1/2 x minus 4. Okay, so now you have to take each one, and you have to now put them, I'm just going to get rid of this, and I'll rewrite them. And you want to put them in general form. So this is general form, how the equation was given. That's general form. All right, so let me take the first one we have, which is y equals 2x plus 22. All right, so I'm going to minus 2x minus 22. Y minus 2x minus 22 equals 0. And the other one, which we had y minus 6 equals negative 1/2 x minus 4. So I have here, it has to be equal to 0. Also, you can't have any fractions. So I am going to, I'll start with the 4. Let's add the 4. So when I add 4 here, I get y minus 2 equals negative 1/2 x. Let's get rid of the negative a half. So I'm going to multiply by negative 2, both sides. That's negative 2y plus 4 equals x. Now subtract the x. Negative 2y minus x plus 4 equals 0. Okay, so that's it, and happy studying. Have a good night.